right, so 8-5 is your only homework for tonight. Tomorrow is going to be a work day, by the way. I know I've kind of piled homework on you guys this week, so tomorrow will be a work day, by the way. Okay, and we might take this vote tomorrow. We may put your work day on Friday, because then you'll have no new homework or anything. So, okay, let's just have this vote now. Would you rather work day tomorrow and finish the chapter on Friday, or finish the chapter tomorrow and then have a work day Friday so you can wrap up all your chapter 8 work?
See.
So, shut your eyes.
What?
Yeah, shut your eyes.
Nobody's gonna...
I don't care. Vote for work day tomorrow.
Oh.
Vote for work day Friday. All right, well, that's pretty unanimous. So, work day Friday. 8-6, the last lesson. All right, so you have a peculiar professor. Peculiar, kind of weird, kind of different. We're all pretty peculiar here.
Professor's perfectly proportional poster.
Exactly. Your peculiar professor, perfectly proportional poster of a photo of her pet paper cup. Say that 20 times fast. So, this is the picture. This is the photo. Most photos, if you print them, you guys have no idea about printed photos, are 4 inches by 6 inches. She says that the poster must be at least 3 feet tall. So identify the 2 possible side lengths of that poster. So I want you guys to set up a proportion. I know you don't have much space on your paper. You can use scrap paper or somewhere that you have extra space, or post it or whatever. What do we need to do in this proportion to make sure that it's true? So we've got a height and a width for your photo, and we want to figure out what could be the new height and width for the poster. Now, obviously, we have lots of options. If she just says it has to be at least 3 feet tall, so we have options here for what we want to do. At least 3 feet tall, scaling up from my 4-inch poster and 4 by 6 inch photo. So try it on here. Take like 30 seconds or a minute. Try this out. Huh? I know it's not on your paper. That's why I said maybe use scrap paper or a post-it or somewhere that's empty on the page. I mean, you can honestly fit it up like right in the top corner.
Just like with I'm not sure if this work. Couldn't it? Would 2 by 3 inches work?
She's scaling up to make it bigger, to make a poster that's at least 3 feet tall. So no, 2 by 3 would not work.
I know.
Alright, well I'm gonna close that with the mouse.
The levers.
I love Kermit.
I do
Kermit
the Frog here.
Everyone
Alright,
did.
Nate, what do you think needs to happen here?
So if she wants it to be 3 feet tall. So that would be, to simplify, that would be 36 inches.
So we can either take 3 feet and turn it into inches,
Or turn it inches.
or we'd have to turn our inches into feet. So you have options here. We could say that 4 inches is a third of a foot, and 6 inches is half of a foot. So one option for my proportion could be 1/3 over 1/2. How do I get that to be 3 feet tall, and then what would be the width? Well, how do I go from 1/3 to 3? Pranav? No? I know, you put it back down real fast.
I thought you do the reciprocal. Okay, I thought you would divide, except I got my order wrong.
No.
You do like 1/3 divided by 1/2, and then you would flip. You would do the reciprocal.
So think about if you have 3 pizzas, and they're each sliced into thirds, how many thirds are there in 3? More than that. 3 thirds gives you 1. Peyton? 9. So if you multiply by 9 on top and bottom, you multiply by 9 here, so we get 9 over 2, which is about 4.5. So we could figure out our 4.5 feet that way, or if we use everything in inches, which I think just using inches would be easier, we'd say 3 over 4 equal to 36 over something. Well, what's this multiplication?
18.
3 to 36? A little bit
12.
smaller. 12. So we multiply by 12 here, and we get 48, right?
48 inches is 4 feet.
Now wait. Why is this goofy?
Because
It's not 4, guys. It's 6. I keep trying to see who's paying good attention and who will catch mistakes in the work.
I don't pay
This denominator was 6. So when we do 6 times 12, what's 6 times 12?
72.
72 inches. Now wait. Why does that not make sense?
I don't know.
Wait,
Is it not?
it's supposed to be 9 or no?
How'd you get 3, 6?
Steve?
3 has to be what do you call it? 4.
Guys, I goofed up this whole thing.
Mister.
What? Why'd you do that?
Because I'm trying to see if you're awake.
I'm not.
So it was 4 over 6.
I saw that first time. Like, what? Wait.
To go from 4 to 36, we multiply by 9. So we multiply by 9.
It's 54.
And 54 inches is 4.5 feet.
Okay. Oh my god.
Just trying to see who's awake.
I'm not. I was wondering where I got
Why, are you scared now?
I'm wondering where you got the 12 in the street.
Alright, let's dive in. So today, no?
Couldn't you make it like 400 by 600 because it just had to be above?
Yeah, you
That'd
could.
be a giant poster.
You could. It would be a giant poster.
Emma Stone. 4,000 over 6,000.
You could.
You could.
So,
It looks like
here's the big thing about today. Out in the hallway, I have a scale map of Ohio because if we had a real map of Ohio, that would be quite absurd if it was the actual size. No one would ever have any purpose to have an actual size map
Be awesome.
because you just use the actual size of whatever it is. It would take a lot of paper, like the entire state of paper. Like if you had an actual size map, right? The actual size of Ohio, it would be as big as Ohio. That's pretty crazy. Like you wouldn't ever do that. So,
There's no.
hey guys, we're having issues with chatter already. So we use scales. And you'll see scale models all over the place. Scales in maps, scale models in cars, scale models in planes, all kinds of things are scaled down. So we have a real boat here that's 15 feet long. We want to talk about a scale boat, 1 inch long scale drawing made of a 15-foot boat. So now the scale drawing is 1 inch. So we can then say that my scale is 1 inch to 15 feet, which I could write in the 3 different ways. And really how we normally use this is we will take this scale and immediately put it as 1 over 15. So we can set up a proportion. I urge you to keep your labels on because if you don't keep your labels on, you might forget that my numerator's inches, my denominator's feet. We're going to do a lot today with numerator and denominator having different labels, which is fine as long as your next numerator was inches and your next denominator was feet. So it's all about you got to match up your labels. Top's got to match top, bottom's got to match bottom.
How do you empty this thing?
Can't hear you.
How do you empty this? It's like.
You pull it apart, but do it above the trash can because somebody did it all over the floor.
No, it's dead.
I think my smartboard's slightly easier to see with this bank of lights off too. So this is how we set it up. We either put inches over feet or feet over inches. We can use either of them interchangeably. So when we have this, we see that from, what's it say? The American golden plovers migrated from Nova Scotia to South America every fall. So I think those are birds.
It's in Canada.
Yeah, so this is the U.S., so we are approximately here. Maybe a little bit more south than that. But this is just a really crude map of the U.S. So if we drag this over, and I forget if I moved it on your paper. No, I didn't to show this. When we drag this over and we rotate and we figure out how far it actually is, I want to line up my 0 inches. How many inches? 6. So I want to see how good you guys are. Even though I haven't done one for you yet,
You made a mistake?
try this.
Never mind.
No,
Is that
I haven't.
inches?
Yes, so this scale is in inches. This ruler is measuring inches. You have your scale relationship right here.
Hey, I had it first.
Everybody should just be doing it on their own. I'm going to do it on my own, but with the board frozen so you can't see it.
I think I got it.
It was.
So if this writing is messy, I apologize, but I'm trying to keep it secret from you guys.
Wait, can the people who are watching the video take it?
Yeah.
I went and I did it.
What'd you get? Just give it to me.
2,500 miles.
2,400 miles. Because when you set up, the first thing you set up is your scale. Your inches over miles is always the first thing you write down, and keep your labels. Then I look at, well, how do I go from 1 to 6? It's just times 6. I do the same thing on bottom, and I get 2,400 miles. Shahid?
I just got rid of the zeros. I did 6 times 4, 24, and then added back to 0.
Yeah, you can do that. Yeah. Questions? All right. Try the got it there then.
Yay.
We're going to breeze through this. Might have some time to work on homework. So it shows you. Now, you have to determine how far each tick mark represents. So most of the time on rulers, it's broken up into quarters. So here's my quarters. So 1, 2, 3, 4 tick marks gets me to a fourth. So this is 1 and 1, 2, 3, 4 tick marks. This is actually 1 1/4 inches.
So you would do an inch divided by 4 to find the, or like how much miles they are divided by 4 to find the, divided by 5.
Yes. Yeah.
Take your headphones off.
I should really get out cards.
Or a decimal?
Because we're dealing with inches, we would normally use fractions. Yeah, that's a great question, actually. In the metric system, you can use decimals, but in the American Standard System, we normally use fractions because what's the base of the American Standard System of measurement? But what number is our base? If we're talking inches, stop.
2, 1.
How many inches are in a foot?
12.
So your base conversion is 12. Then, if you try to go from feet to miles, your base is 5,280. So the metric system is always base 10. Every time you step up, it's always times 10. Doesn't work that way for ASE. Riley is out.
Wait, can I?
I got cards. Pranav,
What?
what did you put where on the other side of your proportion?
Well, I didn't finish it yet, but
Why not? You're back there talking.
I'm doing it on paper. I put on the other side. I put 5 over 4, and then converted it into a.
Like you put 5 over 4?
Not equal, but okay. Yeah, I think I did my math wrong.
Can I try?
Never mind.
Oh wait, I did it without a calculator. Dang it.
Leah, do you know what needs to go where? Karen?
So if 1 inch equals 110 miles, then a quarter of an inch would be 100 divided by 4, right?
Yeah.
And then that would equal 27.5.
So you kind of broke it up into the related, like you made it more like I have 1 plus a quarter.
Yeah.
So then you said my 1 is 110, my quarter was how many did you say?
27.5.
27.5. So that is one way that we can do it. We can break it up into what we know and then divide. But there's still, like, that's not the easiest way. That works, so I'm going to capture that. But that's not the easiest way to do it. Well, depending on, and remember, easy is all relative. So when I talk about easy, I talk about like simple, straightforward. Ella?
So I made 1/4 into an improper fraction.
Ah, what is that?
It's 5/4.
Where does that go?
And then you have to multiply it by 110.
Yeah, so that 5/4 all goes in the numerator since that is just inches. So really you just need to multiply your 110 by 5/4, which if I do that, I get 550 over 4,
Oh, I got 137.5.
which when you simplify that, 137.5, which we would really say 137.5 miles. So almost 138 miles.
I like this. That sounds cool.
I know, I love it.
Yeah, I'd rather have a cold room than a really hot room.
You can always put on a jacket.
I'm wearing a jacket.
Well, then you've already done that. Good. I can't really do much else for you. I'm sorry.
I like your color than it being 90 degrees. I like your color combo today, Mr.
Well, thank you. All right, so
I feel like orange laces.
when we're writing our equation, our constant of proportionality, or our scale that we're given, can be written inches over feet and feet over inches, but the question is, how do we determine which way it should be? How do I determine how I want, really this is my m value, it's my multiplier, it's also the constant of proportionality. So when we talk about m, how is m determined? How do we find it? When we talked about the constant of proportionality yesterday, how would we find generally, like kind of ignore the scale that we've been given right now, how do we generally find the m value? Think?
When you, well, like in the last problem, or the example, you found it by, like measuring to see what it was, like the scale of it.
Yeah, but like I'm talking like in any situation where we have like x values and y values. Peyton?
Y divided by x.
It's always the y over the x. So you, and I would write this down because some of you are struggling to see that and remember that. When you set up 1 inch over 15 feet, that tells me that the 1 inch, that y is going to be inches. So whatever this y value is inches. And then it tells you that the feet is going to be your x values, and that x would have to represent feet. It works the other way around if you put 15 feet over 1, because that tells you that your 15 feet was your y value, and that y will be in feet. And then that your 1 inch is really your x value, and that your x there is going to be in inches. So that's how you determine what goes in your numerator or your denominator is what has been given as y values and what has been given as x values.
Is the top always the one?
The top is always the y. Now when we get further into this, and when you're dealing with slope equations with y equals mx plus b and m is your slope, m is found with change in y over change in x. The triangle delta means change in, but that's more when we get to geometry and we get to graphing things. I can really just clear all this. So, this is why we care.
Is that a mercury? Is it supposed to be a mercury?
I think. Alright, the one issue I have with Columbus's zoo is our aquarium's not that great.
No.
We need a better aquarium.
It's tiny.
So our scale, as we've been using, 1 inch to 1.5 feet. A lot of times you're given scale in inches to feet, or, depending on the size of the map, inches to miles. So actually if you go and look at that map, it doesn't tell you 1 inch equals this many miles. It has the actual scale, and it says this distance is this far in miles. Like, and you can measure out what is an inch. I forget what the scale is on that map. But considering it's a map of Ohio in about this much space, it's inches to miles. So, how do we set this up? Who can give me some advice?
Oh, I just wanted to say there's an actual aquarium called Monterey Bay.
Oh, yeah. Isn't that like a water park too?
Is that in Mexico? No, I think
Okay, who
it's
can
more
set
like-
up my
there's a-
proportion for
there's a
me?
city that's
We've already
called
talked
Monterey.
about it. Ashton? Card. What do we start with? What do we always have to write down first?
We need to write down 1 inch, 1 and 5/10.
Yeah, exactly. 1 and 5/10 of a foot. So we always start writing down your scale first. So since nothing has been told as X or Y values here, we can choose what way we do it. I like my inches on top for really no reason. Just because normally it's given to me in that order. So I can then say 1 inch is 1.5 feet. It says, what are the actual dimensions of the billboard if this is the sketch? This is the drawing. It was made to like fit on a piece of paper so you could look at it. But we know that every inch of the drawing in real life on the billboard will be 1.5 feet. So, Shahid, what do you want to put where?
For 8, it would be 8 times 1.5.
Yeah, so we put that on top, which what Shahid was already jumping to is to solve this, we can cross multiply, or we can say how do we go from 1 inch to 8 inches, and we do the same thing on bottom. But really, whenever you're given a scale, since I have 1 inch on top, that 1 is not going to affect my variable. It just keeps it as 1x. So x is really equal to 8 times 1.5, and that'll be feet. When I do that, my x is equal to 12 feet. So it will actually be 12 feet tall. Pretty good size. I set up another proportion. Don't try to do these all in one proportion. So I set up again 1 inch over 1.5 feet equal to what goes where now? Grace, can you help me out?
16 over X.
Yeah, I put 16 over my x. Again, my 1 inch does not affect my x, or I can look at it just like this and say we need to multiply by 16. So x is 16 times 1.5, and that'll be feet. So x is 24 feet. So that billboard would be 12 feet tall and 24 feet long. And notice my original height compared to width, my height was half of the width. My height is still half of the width. The other thing you could have done is as soon as you found 12 feet for the height, you could make the statement that if my width is twice the height, then my width must be 24 feet. So I'm actually going to change these labels, considering this is width and this is height. Questions? Try got it with the handicap sign.
Are you fading the campus too?
No, but I got a comment on my video from yesterday, but I deleted it because I think it was like a spam sort of thing. It just said click here and had a link. I was like, no way, no way. If you don't know who somebody is and they send you a link and it just says click here, never do it. Yeah, and then you'll get malware or spamware or something put on your computer. See, that's correct, but be careful that you would know how to set up the proportion. Because like I will on the test say like set up the proportion and solve. Got a little stash there.
Yeah.
I'll make that disappear.
You
Really
can
do
lead by
like Mr. Goodbars though.
You can lead by taking it away. Just like
Yeah.
Yeah, I know. But I like.
But I have the power to take it away. That's the thing.
I know. And
don't abuse your power, Mr. Johnson.
So now Ella used an interesting technique for this. Do you want to explain your technique, Ella?
Sure.
Because she didn't set up her proportion. And I cautioned her, like, yeah, your answers are right, but be careful. So what'd you do?
I did 0.5 feet times 2 inches, and that equals 1 foot.
So Ella's brain said, wait a minute, if every inch is half a foot, then 2 inches, well, each of those inches just needs to be multiplied by half. So Ella, when I looked at her paper, just had 2 times 0.5, which is 1, so that'll be 1 foot. She did the same thing for her 3 inches, did 3 times a half, and got 1.5. You can do it that way, but that only works if we have one of the unit that our scale is given in. So if we set up a proportion, you want to talk me through actually if we do a proportion, Sheeb?
We would put 1 over 0.5.
Always include your labels.
And then 2 on top, and then X or
Yeah, I'm going to do W for width.
and then you just multiply 2 times.
Yeah, so you can see this is a times 2. So we'll times 2 here, and that means that W is
But
1 foot. Now, I will caution you, you can do this, but be careful in doing it. This will also be proportional to the height that was 3 inches. So now we'll get the height of the actual. Then we can say, oh, to go from 1 to 3 is just times 3. To go from 0.5 to the actual height would just be times 3. And we get 1.5 feet. So we can set up a string of proportions and just keep working from the original one, or you can put the original scale proportion in the middle.
can you do it with like 3D objects, like
What do you
putting
mean?
it to scale? Like if
Yeah.
you did the same thing but with one more. Like,
Yeah, so like a scale, like when you get a scale model like of a race car or something, that is literally like it'll be 1/15th scale or 1/20th or 1/40th or 1/50th depending on how big the actual object is. Every dimension that you could measure on that car, length, width, height, any of that, if you multiply it by the scale factor, would be the actual size. So like the steering wheel inside the car, if you measure it and multiply by the scale factor 40, let's say if it was a 1 to 40, that real steering wheel is 40 times that model one. So, but it's hard to get accurate measurements when you're that small.
and you have more things to measure. 'Cause
Yeah.
it's not a perfect shape.
So try this now. What is the scale? A tennis court is actually 36 feet wide, and a scale drawing of the court is 2 1/4 inches wide, 5 1/16 inches long. I want you to figure out what is the scale, and then to take it a step further, what's the actual length? Because they only give you the actual width, so we want to figure out what is also the actual length. So take a minute to solve this. It's been in my head since last time. Sweet, thank you. Anybody else have math counts forms? Anybody else interested in doing math counts and just hasn't been able to make it to a meeting? Yeah? I'm gonna get you a form.
Mr. Hudson,
Yeah.
can you like simplify? Never mind. That's a stupid question.
There are no stupid questions.
There are.
It's like, no, you
Like
must not
what's
know.
0 plus 0?
How do you breathe? Or is -0 a number?
I like to call those irrational questions. They don't quite make sense. They're not stupid. They don't quite make sense.
Basically,
If you're interested there, we don't know when this is going to happen yet, but we do know our big competition that we go to is for
and is mayonnaise an instrument?
All right, so
Patrick, either are horseradish.
Carrie, can you tell me how you got the scale? Have you found the scale? Has anyone found the scale?
I have a question.
Question? Go
Well,
first.
actually, I just want you to see if I'm on the right track. I'm not finished.
Okay.
So what I did was I simplified I didn't simplify, but I made the mixed numbers into improper fractions.
Okay. So this will be
9/4,
9/4, right?
and then the other one will be 81/16.
Okay, 81/16.
And then you would multiply those two, right?
I'm asking for you to
Yes.
tell me.
You multiply the two. Yeah, you multiply the two fractions. I haven't gotten that yet.
You don't.
Dang.
So,
You could have told me
Peyton?
before I embarrassed
I
myself.
try this.
I didn't know what you were going to say multiply by. We do have to do a multiplication, Nate. So don't worry. We are going to multiply.
So I don't know if this is right.
Okay.
So I did 9/4 is equal to 36. And then with inches.
Oh, it smells so good.
I'm going to cautiously go ahead and write down what you're saying.
Okay. And 9/4 is inches.
Yeah.
And then 5 1/16 is 81/16.
Okay, so you jumped right to finding the length.
Yeah.
But we want to find the scale first. Because if we can find the scale, then life gets easier. Here is what you want to do. You want your scale, so I need all of you guys with me because apparently we're struggling. You want your scale to be inches compared to feet. So set up a proportion where you're going to have inches compared to feet. Now the only inches compared to feet that we know is that 9/4 of an inch is 36 feet. Now what we want for our scale is to have 1 inch equal to some amount of feet. How could I turn 9/4 into 1?
You subtract.
No, we're going to multiply here, like I said.
You're
Zach,
going to multiply.
do you know what we're going to multiply by, Zach? Karen?
4 reciprocal of 9/4.
To turn any number into 1, multiply by exactly what Karen said, the reciprocal. So we're just going to multiply by 4 over 9 on top. That gets me to 1. And that means I have to do the same thing on bottom. So what I really have is 36 times 4 over 9. Well, I can make 36 over 1. I have some cross canceling that can happen. Nate?
36 divided by 9 is 4.
So I get 4. This turns into 1. I really get 16 over 1, which is my answer right here. So 1 inch is just 16 feet. Did you have kind of like a complicated method to get there, though?
Look at it.
Look at it. Look
Look
at
at it. I don't know how I did that.
Go to your happy place, baby.
See, but the problem is if you don't know how you did it, like, so you took 36 and divided by 9/4. When you divide by 9/4, you're essentially multiplying by 4 9ths because you can flip.
So I did it.
Yeah.
Yay!
But this is the easier method to use on your homework. Decide which one you want to be a 1 and then make it happen. So since I want my inches to be 1, I take my inches and multiply by its reciprocal. Then, since I know my scale now, 1 inch to 16 feet, I'm going to capture this and then solve for the length. So I can use that scale, 1 inch over 16 feet, to solve for if this is, it was 81/16.
Yeah.
So here's what's nice. To go from inches to inches are times 81/16. Well, when I multiply down here times 81 over 16, this is really 16 over 1. The 16s cancel out, and I just get 81 feet. That easy.
I had that too.
It is that.
I want it. Oh, I just got
It is.
rubber.
It is that easy once you think it through.
Oh, that burns a little bit. It's okay.
Very talented.
My knees are good.
So now we're given the scale. This is probably the questions that I see people make the most issues, because I will tell you there are 2 parts to solving this question. I need your eyes up here, please, because I already feel like some of you are working ahead and you may not be doing the right thing. This is a scale drawing. This is how big Kansas is on the map you're looking at. But you want to draw a Kansas that is a different size, but still not the real size. So first, we have to take our scale and figure out the actual. Then we have to take the actual and convert it to the new scale size. So, step 1, find out what the actual is. Pranav?
I just have a question.
Okay.
Wouldn't the like cut on the side if that's going?
Well, it's just giving the approximate lengths of that. So step 1, we take the scale that it used. It says the map below uses the scale of 1 to 100. So since I'm converting to find the real, I use my 1 centimeters to 100 miles. And guys, this is where I'm going to put this in the middle. So to deal with the height of Kansas, I put 2.1 on top. You can't really see that decimal. 2.1. How do I go from 1 to 2.1?
Multiply by 2.1.
Multiply by 2.1. So 100 times 2.1
is 2,100.
close. 210 miles. So the actual, and I write this over here beside it, it's actually 210 miles. I do the same thing with the width, and now I'm just going to go the other direction. How do I go from 1 to 4? Well, that's easy. Multiply by 4. We do the same thing. We get 400 miles. So step 1 is now complete. I have found the actual dimensions of Kansas, approximately. I don't want to get a call from Kansas and say, we're not that size. Then step 2, I'm going to take the actual values and the new scale. So I'm going to take the actual values and the new scale and convert to my new drawing sizes. So if I use the scale of 2 centimeters, actually I'm going to use a different color. 2 centimeters to 125 miles. So we have the width is, now pay attention, since I have the actual length and width now, or length and height, can you be writing this down with us, please? Zach? My actual now has to go on bottom. Because I don't know the height or whatever we want to call it. We'll call it H since on our paper it looks like the height. Now there's no easy way to go from 125 to 210. We could divide to figure it out, but easier than that is just cross multiply. Question or hang on, because then your question might figure itself out. So when I cross multiply here, 2 times 210 gives me 420 will equal my other cross multiplication, which is my height times my 125. So 125 times h. To get the h by itself, Karen? Yeah, really, I divide on both sides. So be careful saying move because we just have to do it on both sides. So then my height becomes, well, 420 divided by 125. 3.36. And since it's centimeters, that's fine to leave it like that. So our height is now 3.36 centimeters.
Oh yeah, I found it easier.
We're going to do the same thing for the length, but I wanted to capture that before I run out of space. Zach?
Since what I did was I did 125 divided by 2.
Yeah, you found the unit rate
Yeah.
of miles per centimeter.
And then it got 62.5. And then you do one.
You just multiply that by however many
Yeah,
centimeters you
yeah.
have. Yeah, so Zach took this scale and found his unit rate. He said 125 divided by 2 gives me the miles per centimeter, per 1 centimeter. So he found that to be 62.5. So then for every centimeter he has, it's, for every centimeter he has, it's 62.5 miles. Here's the issue though. When you find the unit rate of miles per centimeter, we now have to use the miles value. So we would still kind of have to set up a proportion or just do the division of 210 divided by 62.5. And if you do, it should work out the same. 210 divided by 62.5 is 3.36. It's exactly the same value. Shahib?
I did 210 divided by 125, and I got 1.68, and then I times it by 2, and I got.
So instead of cross multiplying and then dividing, you divided and then multiplied. And because multiplication and division are essentially the same, you can, in some cases, do them in different orders and be okay. Nate?
I have a question about the state.
Okay.
Why aren't like all the states like even shaped?
So when they came over, they hit the eastern seaboard, right? And they were laying out states, especially based on waterways, rivers, and things like that. As they got further west, it got more and more boring. So they just started to say, okay, this plot of land is this state. This plot of land is that state. That's why they kind of get more boring. Then they hit the west coast, and they have to, deal with the coast. So they get a little bit interesting again.
Why are the states? Why are not all the states?
Because they weren't all made at the same time. We had to get there.
If they were done, couldn't you just do
Real quick, because then we got to go. Sorry, I'm just trying to get you guys out of here. I can do the same thing to figure out the length of the state. If I just take that proportion and take my 400 miles now, and I don't know how many centimeters, so I would cross multiply again. 2 times 400 gives me 800. Will equal 125 times, we'll say L for the length. And we divide by 125.
That's like
6.4. So now this we just said is 6.4 centimeters on my new map or my new drawing. And the new height was 3.36 centimeters. So these are my final new values after step 2. So anytime you see 2 different scales in your problem, you know it's going to be a 2-part question. Take the scale to the real, then the real to the new scale. Cool?
Bye-bye.
Have a good day, guys. There is no try. There's only do. Or what? There is no.
Do or do not.
Yeah,
there's
I
no
know.
try.
It's said the other way around, but yeah, it's do or do not. There is no try.